over x squared minus 49 times x squared minus 11x plus 28. Question. Is this thing a fraction? No, but we can make it 1. We can put the whole thing over 1. So that's always what I do first, is I put the whole thing over 1, and then rewrite it as a fraction. Okay? So let's start factoring things. This numerator, can I factor that? Yeah, I can use diamond. What two things multiply to negative 36 and add up to positive 5? Positive 9 and negative 4. All over. What method is this one? The denominator. It's difference of two squares. So that's going to be x plus 7 times x minus 7 times. Okay, this one, what method will I use to factor that guy? Diamond again. So I'm looking for two numbers that multiply to 28 and add up to negative 11. X minus 4, x minus 7. All of that is over 1. Okay, so far so good? Okay, so what can cancel now? X minus 7 and x minus 7. Anything else? Do the x minus 4's cancel? No, we can only cancel if one is in the numerator and one is in the denominator. Because whenever I divide a number by itself, what does it turn into? 3 divided by 3 gives me 1. So we are only canceling them because they actually will end up dividing and turning into 1. In this case, we're multiplying them. So we can only cancel one on top for one on bottom. If they're both on top, you have to multiply them together. Okay, so what is left in my numerator then? We have x plus 9, right? Times what? Times x minus 4 squared. Why is it squared? Because we have two of them. You could write it x minus 4 times x minus 4, but this is a lot easier, smaller. Okay, and then what's left in the denominator? X plus 7. Okay, questions on multiplication? You guys are good? Okay, last two examples. We are dividing, and I want you to write these steps. The good thing about dividing is that it's actually the same as multiplication. I do want to make one change though, so before you start writing it all down, will you please make step 2 step 1 and step 1 step 2? I decided during second period that I wanted you to switch the order. Okay, so what we're going to do, step 1, how many of you have heard of KCF before? Keep it, change it, flip it? Yeah. Okay. Step 1, you're going to do KCF, keep it, change it, flip it. Or you're going to keep the first term, change the division sign to multiplication, and then you're going to flip the second fraction, so you're going to take the reciprocal. Okay, then step 2, I want you to factor both the numerator and denominator. And then step 3, it's just a multiplication problem. So you're going to cross-cancel and simplify. And the reason why I decided to change these is because a lot of times I see that if you factor first, you'll start canceling things before changing it to multiplication. And we can only cancel things after it's changed to multiplication. So it's better to change it to multiplication first. Okay, so we're going to make it a multiplication problem first, then factor, then cancel. Okay. Example 10. Example 10 is a lot like example 7, where there is going to be no factoring to start with, but it still is good to practice the canceling. So we have 5x squared, y to the third, all over x to the 7th, divided by 30xy to the fourth over y to the third. Now, first step, I want to change it to a multiplication problem. So I am going to keep it. So 5x squared y to the third over x to the seventh. Change it. So we change our division to multiplication. And then we flip it. So this second fraction becomes y to the third over 30x y to the fourth. So what we're really doing in division is multiplying by the reciprocal. Okay? Now, like I said, I go from left to right. So starting with the 5, what can cancel out with the 5? 30. 5 goes into 30 6 times. What about the x squared? There's an x to the 7, so all of those will cancel, and this would become x to the 5th. We also have y to the third, which will cancel with 3 of these y's, so that becomes what? Y. Just y. But I have y to the third on top and 1 y, thank you, on bottom. So some of those are going to cancel too, right? Yeah. This y is going to cancel with 1 of those, so it becomes y to the second. And then we multiply straight across. So we have 1 times y squared, which gives me y squared, all over 6x to the x to the 5th times x to the 1st. That's going to be x to the 6. And like I said before, if you want to multiply this out first and then reduce, that's okay too. Okay? It's just one extra step. Example 11. I know. It's not as bad as it looks. Okay, example 11. X squared minus 6x minus 27 over 2x squared plus 2x divided by x squared minus 14x plus 45 all over x squared. Okay, so what's my first step in division problems? I want to change it, keep it, change it, flip up. I want to change it to a multiplication problem. So this is going to become, we keep the first one, x squared minus 6x minus 27 all over 2x squared plus 2x. Change it, times, and then we flip it. X squared over x squared minus 14x plus 45. Oh, we're not going to, no, we're going to factor first. It's going to make it so much easier for us. Okay, yeah, you could multiply the numerators, multiply the denominators, combine like terms, then factor, then reduce. But if we factor first, it's going to be a lot easier. So let's look at this first term. In the numerator, can I factor that? Yes, I'm going to use diamond. So what two things multiply to negative 27 and add up to negative 6? Negative 9, positive 3. All over? How does the denominator factor? 2x over x, or times x plus 1, times x squared doesn't factor, so we're going to leave it. And then does the denominator factor? Yes, it does. It becomes x minus 9 and x minus 5. Okay. Last little bit, we need to cancel anything that we can. I see x minus 9. And I have an x right here and an x squared on top, so that cancels with one of them. So what is my answer going to be? In the numerator, I have x times x plus 3, and we can just leave it like that. We don't have to multiply it all out. All over, what's in the denominator? 2 times x plus 1 times x minus 5. And you can leave it factored like that. So that is perfectly okay.